Ever since the dawn of human existence, we've been doing the same simple thing. We look up, into the dark. Not because we expect answers, but because something inside us needs to ask. And the question has never changed. Are we alone in the universe? It's a terrifying question, because no matter the answer, something about it is unsettling. If we are alone, then the universe is unimaginably empty. Endless space, endless time, and no one else. And if we're not, then something else is out there. Something that evolved, somewhere else, under different stars. Not a myth, not a story. Something real, watching, waiting. And humanity has never been very good at letting fear stop curiosity. We build tools. We build machines. We listen. From Galileo's first telescope to satellites orbiting Earth, from the James Webb Space Telescope to massive radio dishes patiently listening for whispers in space. We keep searching, quietly, patiently, hoping for just one thing. A signal, a flicker of light, anything that proves we're not alone. Because if the darkness ever answers, it won't answer loudly. It won't announce itself. It will arrive quietly, unexpectedly, and by the time we notice, it may already be here. Tonight, we follow the evidence. Welcome to the truth. Humanity has never stopped searching. Not because we expect easy answers, but because the question itself refuses to stay quiet. For thousands of years, we mapped the stars by hand. We told stories about gods in the sky, messengers, watchers, and then we learned how to listen. Galileo was the first to truly look beyond our world. A simple telescope, a radical idea, that the universe was larger and stranger than we had ever imagined. From that moment on, there was no turning back, because once we understood that the universe could be studied, it stopped being a mystery meant only for belief. It became something we could test, measure, question, and doubt. We learned that stars are not symbols, they are engines. That planets are not lights in the sky, but worlds. Some hostile, some silent, and some possibly alive. With every new discovery, the silence became heavier. Because the more we learned, the more obvious it became. If life appeared here, under these conditions, then statistically, it should have appeared somewhere else too. We launched machines into orbit. We built eyes that could see farther than any human ever could. And eventually, we stopped looking with light alone. We began listening. Radio telescopes spread across deserts and valleys. Quiet machines designed to hear whispers from across the galaxy. Because intelligent life, if it exists, wouldn't shout. It would transmit, patiently, precisely, on frequencies that never change. This search has a name: SETI, the search for extraterrestrial intelligence. For decades, it listened to the sky. Most of the time, there was nothing, just static, cosmic noise. Until one night, something answered. It happened on a quiet summer night, August 1977, Ohio, at a radio observatory known as Big Ear, a machine designed to listen, not to people, but to the universe. Astronomer Jerry Eman was doing what he had done countless times before, reviewing data. Long sheets of paper covered in numbers. Most of it was meaningless, static, background noise, the sound of nothing. Until suddenly, one signal stood out. It wasn't loud, it wasn't dramatic, but it was different. For exactly 72 seconds, the telescope picked up something no one had ever seen before. A narrowband radio signal, strong, focused, coming from deep space, from the direction of the Sagittarius constellation. Eamon circled the signal on the paper, and next to it, without thinking, he wrote a single word: wow. The signal was detected at 1420 megahertz, the hydrogen line, the most common element in the universe, a frequency so universal, so fundamental, that scientists had long believed any intelligent civilization trying to communicate might choose it. And then, just as suddenly as it appeared, the signal was gone. Never repeated, never traced again, as if someone had pressed a button and then let go. What made it even more unsettling was its precision. The signal didn't drift, it didn't wobble. It stayed exactly where it was, locked to a single frequency. Too clean, too focused, too intentional. And then it vanished, as if the universe itself had decided to say no more. For decades, scientists searched for it, pointed telescopes back to the same region, listened, waited. But the universe remained silent. And the wow signal became one of the greatest mysteries in the history of astronomy. A message, or just a coincidence? No one knows. But it proved one thing: the silence was not as simple as we once believed. Several decades after the wow signal, the search continued, quietly, methodically. This time, not through radio waves, but through light. In 2015, NASA's Kepler Space Telescope was scanning distant stars for signs of planets. Tiny dips in brightness, predictable patterns, simple physics. Until one star refused to behave. Its name was KIC 8462852, better known today as Tabby star, located nearly 1,500 light-years away. At first glance, it looked ordinary. But when scientists examined its light curve, something was wrong. Very wrong. Normally, when a planet passes in front of a star, the light dims by about 1%. A smooth, regular, understandable dip. But Tabby's star didn't follow the rules. Its brightness dropped by 20%. Sometimes more, sometimes less, and without any pattern. No rhythm, no repetition, just chaos. The data made no sense. And when data stops making sense, questions begin to form. One idea, quietly discussed at first, was proposed decades earlier by physicist Freeman Dyson. What if an advanced civilization had surrounded its star with massive energy-collecting structures? Not a single shell, but a swarm. A Dyson swarm. Such a structure would block starlight in irregular ways, exactly like this. The idea was unsettling, extraordinary, and deeply controversial. Because if true, it wouldn't just suggest life. It would suggest a civilization far beyond anything we know. In the end, most scientists favored a simpler explanation. A massive cloud of dust, fragments of comets, debris from a shattered moon. Natural, messy, imperfect. And yet, even today, the possibility remains. Small, but not zero. In October of 2017, something unexpected happened. While scientists were busy searching the distant universe for life, the universe came to us. Astronomers detected an object entering the solar system on a trajectory that didn't belong here. It wasn't orbiting the sun. It wasn't slowing down. It was passing through, fast. Its name came from the Hawaiian language, Oumuamua. It means a messenger from afar. And the name fit perfectly, because Oumuamua was the first object ever observed to originate from outside our solar system. An interstellar visitor. At first, it was classified as an asteroid. But that classification didn't last long. Oumuamua was unlike anything we had ever seen. It was incredibly elongated, roughly 400 meters long, and only a fraction as wide. No known asteroid had such an extreme shape. Even more puzzling, it showed no visible tail, no cloud of gas, no dust trail, nothing that would mark it as a typical comet. And yet, as it moved away from the sun, it began to accelerate. Just slightly, but measurably. Something was pushing it. This was not a guess. It was measurable. Precise calculations showed that Oumuamua was gaining speed without any visible source of thrust. No exhaust, no debris, no obvious mechanism. To scientists, this was deeply unsettling, because space does not give free acceleration. Every movement has a cause, and Oumuamua's cause was hidden, invisible, or unknown. For the first time, something from beyond our solar system was not just passing through. It was behaving in a way we could not fully explain. Normally, that kind of acceleration comes from outgassing, frozen material vaporizing under heat. But if that were the case, there should have been signs. There were none. No dust, no debris, no clear explanation. And for the first time, the question was no longer theoretical. Something unknown had entered our neighborhood. And then, without slowing down, Oumuamua was gone, back into the darkness, leaving behind more questions than answers. As Oumuamua disappeared into the dark, the questions it left behind did not. Most scientists were cautious. They searched for natural explanations, unusual ones, but still grounded in physics. And for a while, that seemed enough. Until one voice stood apart. Professor Avi Loeb, an astrophysicist at Harvard University. A respected name, not a fringe figure. Loeb asked a question many were uncomfortable with. What if Oumuamua was not natural? What if it was artificial? He proposed a radical idea, that the object's acceleration could be explained if it were extremely thin, light enough to be pushed by sunlight itself. A light sail, a technology humanity has already begun to explore. In this scenario, Oumuamua wouldn't be an alien spacecraft, but it could be debris, a fragment left behind by a distant civilization. The reaction was immediate. Some called the idea irresponsible. Others called it speculative. Too extreme. Too disruptive. But Loeb made one thing clear. Loeb reminded the scientific community of something essential. Science does not advance by protecting comfort. It advances by confronting what does not fit. History is filled with ideas once considered absurd. Continents moving, invisible particles, planets around other stars, all dismissed until evidence forced a change. Loeb argued that Oumuamua deserved the same treatment. Not belief, not fear, but honest examination. Because dismissing a possibility simply because it feels uncomfortable is not skepticism, it is avoidance. He was not claiming certainty, only possibility. Because in science, ignoring an anomaly can be just as dangerous as exaggerating it. And Oumuamua was an anomaly. Whether artificial or natural, it forced scientists to confront an uncomfortable truth. We might not understand everything that passes through our cosmic neighborhood. In July of 2025, it happened again. But this time, the anomaly was impossible to ignore. Astronomers using the Atlas survey in Chile detected a faint object moving through deep space. At first, it was given a temporary name, A11P-L3Z. Nothing unusual, until its trajectory was calculated. What they saw changed everything. The object's path was not elliptical. It was not bound to the sun. Its orbit was hyperbolic, extremely hyperbolic, with an eccentricity greater than 6. That meant only one thing. This object did not come from here. It came from interstellar space. It was later named 3I Atlas, the third known interstellar object ever detected passing through our solar system. And it was moving fast, incredibly fast, nearly 68 kilometers per second. But speed was only the beginning. As 3I Atlas approached the sun, telescopes noticed something strange. A tail, but not where it should have been. Instead of trailing behind the object, the dust appeared in front of it, as if the object was pushing against space itself, as if it was slowing down. That alone raised eyebrows. But then came the color. As Atlas neared the sun, its emissions shifted. Not red, not yellow, but blue, a color associated with extreme energy. In astrophysics, color is never just color. It is information. Blue emissions, in particular, often indicate ionized gases, materials stripped of electrons by intense energy, processes we usually associate with stars or powerful cosmic events, not with small objects drifting quietly through space. At Atlas's distance from the sun, such emissions were unexpected, unusual, and difficult to explain. Even more puzzling, its acceleration did not match what gravity alone could produce. For an object of this size, there should have been a massive cloud of debris. There wasn't. Instead, Atlas behaved with efficiency, as if every movement was calculated, not chaotic, not random, precise. With high temperatures, with processes that rarely occur naturally at such distances. Once again, the data refused to behave. And once again, Professor Avi Loeb entered the conversation. As the story of 3I Atlas spread across the internet, the silence was quickly replaced by noise. Speculation, exaggeration, certainty without evidence. Social media filled the gaps with confidence long before science could. Claims began to circulate that the object was transmitting signals, that it was slowing down intentionally, that it carried messages, patterns, warnings. Some even claimed it was connected to the wow signal from decades earlier. But science does not move at the speed of headlines. It moves at the speed of verification. While rumors multiplied, research institutions around the world quietly began their work. Radio telescopes were pointed toward Atlas. Spectral data was collected. Its motion was tracked, frame by frame, calculation by calculation. And slowly, a clearer picture emerged. The unusual acceleration was consistent with natural outgassing, but not from water ice, from heavier compounds, nitrogen, carbon-based molecules, substances that can sublimate without producing a visible dust cloud. The strange, forward tail was not propulsion, it was perspective. Large dust grains, too heavy to be pushed away by solar radiation, lingering along the object's path. And the blue glow was not energy from a machine. It was fluorescence, gas excited by sunlight, emitting light in wavelengths we associate with extreme heat. In other words, Atlas was not defying physics. It was reminding us how much of it we still don't fully understand. This is how science progresses. not through instant answers, but through patience, through doubt, through the slow elimination of what cannot be true. Every interstellar visitor, every strange signal, every anomaly becomes a mirror, reflecting our hopes, our fears, our desire to not be alone. And yet, science asks us to stay grounded, to resist the temptation of easy conclusions, because the universe is already extraordinary. It does not need exaggeration to inspire awe. This did not make the story small, it made it more honest. Because mystery does not disappear when an explanation is found, it simply changes form. And sometimes, the most fascinating discoveries are not signs of intelligence, but reflections of our own curiosity projected onto the universe. Throughout history, we have searched the sky for answers, for signs, for confirmation that we are not alone. Sometimes, that search takes the form of signals. Sometimes, strange stars. Sometimes, visitors from beyond our solar system. And each time something unusual appears, we face the same choice: to rush toward extraordinary conclusions, or to slow down and listen carefully. Science does not remove wonder, it refines it. Because every discovery, every explanation does not close the door. It opens another one, a deeper question, a quieter realization. That the universe is not something we conquer, but something we learn to understand, piece by piece. And maybe that journey itself is the point. It teaches us how to ask better questions, not just about the universe, but about ourselves. Because in the end, the greatest mystery may not be what is out there, but why we are so eager to find it. And as long as we keep looking up, with curiosity instead of fear, the story is far from over. If this story made you think, if it left questions in your mind, let me know. Your thoughts, your interpretations, your questions. And if you want more stories like this, exploring the unknown with reason and curiosity, a simple like helps this journey continue.